We've got a magic square that uses the numbers from 7 to 15, two numbers put in it already, and we're asked to find out what n is. Okay, well, first up, let's add the numbers from 7 to 15 to work out what the total of these is going to be. There's actually a really quick way of doing this, because if you want to add up 1 to 15, you can actually use the formula for adding up the numbers from 1 to n, which is a half n plus 1. That's the nth term of the triangle numbers. So here it will be a half times 15 times 16, or 8 times 5, 120. And then I don't want numbers from 1 to 6, so I can work out 1 plus 2 up to 6. A half times 6 times 7, that's 3 times 7, 21, and I can subtract them. So it's going to be 120 minus 21, it's going to be 99. Of course, if you're not aware of that, it doesn't take too long to just write them down. Actually, I should be putting pluses here. And that's it, up to 15. Okay, now you could add them one at a time, but there's some shortcuts. For example, 13 goes with 7 to give 20, 12 with 8 for another 20, and 9 with 11. That takes us up to 60. And then here, 70, and finally add a 29. That gets us to 99. So the reason for doing that is that, remember, every row and column is the same, and we know the total is 99, so we can do 99 divided by 3 to give us 33. And this is called the magic number, what each of the rows, columns, and diagonals add up to. Okay, now we're really ready to begin this question. Now, a really quick way of doing this question is to use the fact that the middle number is necessarily the mean of the numbers added up to make the magic number. So in this case, the magic number is 33. We're adding up three numbers to get to it. So the mean is 33 divided by 3, which is 11. The middle number must be 11 for this to work. I'm going to do a little proof of that at the end of this video. I have seen this before, but I never remember it. I'm going to try and remember it now for questions like this. And that would give us 25, meaning that n has to be 8. Now that's quite a niche little bit of knowledge to use to get the answer quickly. So what if we didn't know that? Well, we can use the magic number of 33 to fill in some of the missing numbers. For example, this must be 12. And then, although I don't have another 2 that are adjacent that I can use to get like a row or a column, I can work in terms of n. This must be 21 minus n. So I've gone with this row and this column. And now if I can look along the diagonal, I've got 14 plus n. So if I add 19 minus n, that'll get me to 33. Okay, now if I look along this column, I've got 40 minus 2n. So this must be 2n minus 7. And then here I've got 7. Sorry, this one here, I've got 7. Actually, I've just noticed I can now find this one in two different ways. I can look along the diagonal and along this row. So 7 plus 2n, I could write 26 minus 2n, or using the diagonal, I've got 31 minus n, so I can write n plus 2. And it must be that these two are equal to one another. 26 minus 2n equals n plus 2, therefore 24 equals 3n, n is equal to 8. It's obviously a lot more complicated. You don't have to use that bottom left. There's other, what ways you can figure it out, but you're going to ultimately generate an equation which you can solve to give the answer. And to be like really sure at the end that it all works out, you can then substitute your n in just to check out that we do get the numbers from 7 to 15, and we get the magic number. So this would be 11. 21 minus 8 is going to be 13. So that works. 2n is 16 minus 7. That's going to be 9. Over here, I'm going to get 10. Then I've got 18, so this will be 15. So we've used the numbers from 7 to 15. All checks out. Can be pretty happy with that. Right, final thing is to show that the middle number is the magic number divided by 3. In a 4 by 4 magic square, this is not going to work because you're going to have more than one middle number, but I think it does extend to 5 by 5 and so on. But anyway, I'm just going to prove it for a 3 by 3. Yeah, I've got my 3 by 3 magic square. Let's call A, B, C, D, E, F, G, H, I. Now I know the magic number, which I'm going to call M. That is going to, I know that 3M, 3 times the magic number, is just going to be all of them added together. But another way of working out the magic number is to go along the diagonals. So M is going to be C plus E plus G. And then another way of getting it, see, I'm using the middle number every time here, A plus E plus I. And then I'll go along this row, so D plus E plus F. And then B plus E plus H. So that is actually going to give us 4M because I've actually added the magic number together 4 times. And I'm going to get A plus B plus C plus D plus E plus F plus G plus H plus I plus another 3 lots of E, the ones that I've left out. Okay, and that means that 4M is going to equal this A plus B up to I. But remember, I know that that is 3M. 4M is going to equal 3M plus 3E. And therefore, 3E is equal to M. 3 times the middle number is going to equal the magic number, which means E is going to equal the magic number divided by 3. And that's what I used for the quick method above. Once we'd found the magic number, I divided it by 3. That was the mean, essentially, of the 3 numbers in any row or column or diagonal. That's how we got 11 quickly, and then we got 8 quickly. So yeah, nice little proof just to end things.